So this one says a botanist plants an avocado seed and a peach seed and observes the heights of the trees over time. The graph shows the heights in inches of the avocado tree. Okay. Then it says this function is where t represents time and models the height in inches of the peach tree. And so then we get this graph here, or this function. The peach tree is a function of time. So P of t is equal to 3 times the natural log of t, 2t plus 3 minus 5. So this one we can graph. Okay, there's no real restrictions. We don't have to change the base or anything like that because we can do the natural log. So it is 3 times the natural log of 2t, but I'm going to say 2x, plus 3, close parentheses, whoops. And then, here, I'll make it bigger so you guys can see it. And then minus 5. Okay, so that's what this graph looks like. But what I'm going to do is I'm going to change my settings. So my x seems to go, in other words, or what they call it the t, but my t seems to go from 0 to 10, all right, because I want the scale to be kind of the same. And then it seems to go from -4 to, we'll say 18 in the y direction. So what I'm going to do is I'm going to change the window, and my x appears to be going from 0 to 10. And then my y value seems to go from -4. Did I say 16? Let me see. 16. Yeah, let's make it 18. Oops. So now when I graph it, I'll get a graph that's pretty close to the graph that you see there. Okay. All right. So now if I take a screenshot of that, and I can compare that to this one. It's still not quite to scale, but there's some things that, oh, wait a second. I got to change this because look at this. I can't use that. First thing that I noticed is this. My graph goes way past the y-axis. So I'm going to change I have to change my window a little bit. My x value has to be at like -4, right? So let's see what that does. Yeah, I have to change the scale a little bit to get everything to fit. So I'm just going to do a zoom. I'm going to do a standard fit. And then we'll have to keep in mind that the graph looks different. Okay. So we're going to have to use our noodles on this one. So even though it's not drawn to scale, we could still kind of figure out that the values are definitely different. Maybe I could crop out the part that makes it look kind of like it's to scale. So where I'm going with this is these values are not exactly the same. So this is the peach tree, right? So this is the peach tree. And we'll make it peach. I don't know, is that peach? We'll make it orange. Who knows? So this is the peach tree, right? And then the other tree was the avocado. Oh, that's easy. We'll make that green. That goes over here. And so now we got to compare these two graphs. So it says the peach tree had a greater average change from the second and fourth week. Well, if we go from 2 to 4 and we were to calculate that, no, I think it's because this looks like it goes from, so how do we do that? Well, this is going to be a long problem too, unfortunately. If I look at this point right here, okay, that is 2 comma 2. And from 2 to 4, this one here is 4 comma 5. All right. Now, if I come over here and I look at this one, I don't know what this value is, and I don't know what this value is, but I can find out. So let's see what it is. So if I hit trace on the calculator and I hit 2, I hit enter, that's 0.87 or 0.84. So this is 2 comma 0.84. And then if I pull my calculator up again and I enter in 4, I get 2.2. So right here, I get 2 comma 2.2. Or not 2, 4. So anyways, when you look at that, it really only increases. So I would say 2.2 minus 84 divided by 4 over 2. If I plug that in the calculator, I get 2.2. Whoops, my bad. In parentheses, I'm going to say 2.2 minus 0.84. Oops. Divided by 4 minus 2. I get 0.86. So the slope there are 0.68. Okay. Now if I do the avocado one, I'm going to say 5 minus 2 all over 2 minus, or 4 minus 2, and that gives me 3 over 2. So that is not true. Okay. It says the peach tree had a greater average between 6 and 10 weeks. So then we have to do that same math again between 6 and 10. So we got to figure out what the value from 6 to 10 is. Mathematically. So we go back to the graph and I hit trace again. And I'm going to say 6. Again, that's a fraction or a decimal of some sort. There you go, so you can see it. So what does that tell me? That it's 3.1, right? So when this equals 6, 4, 5, it's 6 comma 3.1. And then I got to do the same thing at 10. Now, another way you could look this up is just look at the table of values, right? I could just scroll down here until I get to 10. So it's 4.4, roughly, if I approximate. So that's 6, 7, 8, 9, 10. And that's the point 10, comma 4.4, roughly. So then to calculate that, I'm going to say 4.4 minus 3.1 all over 6 minus, no, 10 minus 6. Plug that in the calculator. 4.4 minus 3.1. 1, close parentheses, divided by 10 minus 6, which is just 4. So that changes approximately 0.325. For the avocado, from 6 to 10, when this equals 6, it looks like this is 6, so 6 comma 6, and 8, 10 is off the chart, so I don't know why there would even be a question. But it doesn't look like it looks like it's maybe 10 comma 7, maybe, right? So if we were to do that, we'd say 7 minus 6 all over 10 minus 6. So that will give me 1 over 4, and 1 over 4 is, well, it is equal to 0.25, so that's true, right? That one works. The peach tree does have a greater increase, okay? The avocado seed was planted deeper below the ground. Now, what they're talking about is where is it when x equals 0? So what they're saying is the y-intercept, right? This is where it was planted. Now, this graph models this, but we're ignoring this part, right? We're counting from 0 weeks. Remember that this is the time in weeks. So we can define the domain to whatever we want. So even though the equation gives us this stuff, we're only looking at this. Well, as you can see, it's less than -2, but over here, this crosses way over here, which is more than -2 or lesser. So that's representing where it was planted. So this was probably planted about 1.5 inches below the soil, the peach tree was, right? So this was like a -1.5 maybe. And clearly this one here was planted probably about maybe even 3 inches, right? Or 4 inches, but it was planted deeper. So that's a true statement. The peach seed was planted at ground level. No, it wasn't. It's not as deep as the other one, but it wasn't at ground level. What's the last statement? The peach tree will eventually be taller than the avocado tree. No, that's not true because the avocado tree is at 7 inches, where the peach tree is only at 4.4. So I would guess that the avocado tree will always be taller. So I think the only true statements are these two right here. That was a long problem too.